In this next half, we're going to talk about equations of relations and functions. So we looked at functions that were given based on a table. We looked at functions that were given based on a set of ordered pairs. The last way that we're going to talk about is when they're given in terms of an equation. And an equation can very easily be translated into a graph. So we're going to look at this first function right here, this equation y equals 3x minus 1. So in order to graph it, the easiest way we can graph it is just by plotting a table. Okay, so what I want you to do whenever you have things like this is I want you to plot a table of x and y values. So now this is a pretty standard table that you can do. If you go -4, -2, 0, 2, 4, you could do the odd ones if you wanted. This just kind of makes sure you're spread out enough. So what you're going to do is you're going to take turns plugging these 5x values into this equation right here, because this equation relates the y value to whatever x value you choose. So if we plug in x is -4, we've got 3 times -4, which is -12, minus 1, which gives us -13. Then the -2. So 3 times -2 is -6, minus 1 is -7. If you plug in 0, this is 0, and then minus 1 gives you -1. Plug in 2, 3 times 2 is 6, minus 1 is 5, and 4. 3 times 4 is 12, minus 1 is 11. Okay, so that's 5 ordered pairs that you're going to plot, and that's how you're going to see what your equation looks like. Okay, so we go up to 4 on the x-axis, down to -4 on the x-axis. All right, and let's scale this one by 2's. Let's say 2, 4, 6, 8, 10, a little higher, 12, and then we'll go only up to 11, and then down 2, 4, 6, 8, 10, 12, 14, so we can go down to 13. So let's plot these. So at -4, we're down at -13. So that'll be right around there. At -2, we're at -7. So here's -2. We can go down -2, 4, 6, and then go like halfway, right there. 0, -1 would be right there. Remember, we're scaling by 2's. 2, 5, so we can go over to 2, and then up 2, 4, halfway would be 5. And then 4, 11. So that'll be up right about there. Okay, so now since it is an equation, we just randomly picked these ordered pairs. They're not the only ordered pairs on the graph. Equations are going to be continuous, meaning that you actually could connect the dots between all of these and make a full graph out of it. So that's what the line 3x minus 1 looks like. Looks roughly like this. We used a table to kind of approximate. So now, determine whether the equation is a function. Since I've got a graph in front of me, the easiest way is to do the vertical line test. And if you're looking, you can see it would pass because my pen would only intersect that line once at any given vertical line. So it is a function. Okay, is it 1-to-1? Meaning, does each x value go to 1 and only one y value? And does each y value go to 1 and only one x value? So the way you can test this out is by doing a horizontal line test. And your horizontal line would only pass once. So that means basically each y value got traced back to only one x value. Okay, so it is 1-to-1. Is it onto, meaning does every single y value get hit? And it does. Because if you look, you're going to go as high as you can possibly imagine, as low as you can possibly imagine. Every single y value that you can possibly imagine will eventually get hit. So it is 1-to-1, is onto, so I guess we should say both according to the directions. And then whether it's discrete or continuous. Discrete means a finite number of ordered pairs, like the one up above. Continuous means a smooth curve. So this one is continuous. Okay, and then the last little thing we're going to do is talk about something called function notation. So I think you've seen this notation before, but just in case. So for example, this example we could have written like this, like f of x equals 3x minus 1. Okay, and you'd read this, you would literally read it f of x, like a function of x. You could also see g of x or h of x or things like that. And so the way this is written, you can write out different notation like this. So you say g of -2, and what this means is you want to start with your function g and replace the variables with -2. Okay, so that's what we're going to do right here. So g of x is our function that's defined. G of -2 means use your function g, which is right here, and replace all the variables with -2. So instead of this x right here, we're going to replace it with a -2, but other than that, the rest of it should look the same. So you'll still have the cubed and you'll still have the -3. So this is just like a fancy way to say that you're going to plug -2 into the function. So now we simplify. So -2 cubed gives us -8. Remember, it still comes out negative because a -2 times a -2 is a +4, but then times a -2 again gives you -8. And then -3, that simplifies to a -11. Okay, and then we can do the same thing even if there's another variable in here. Because literally, like I said, all this means is replace the variable with a 2t. So instead of x, we're going to replace it with a 2t cubed minus 3. Notice how these two are exactly the same. I'm just replacing the x with something different, and it depends on what you have in parentheses. So 2t cubed would be 2t times 2t times 2t, which would be 8t cubed. Don't forget to cube the 2 as well as the t. Minus 3, and then since these aren't like terms, you can't combine them at all. So that's as far as your answer can go. All right, that's it.